Today we're on page 8 of our Chapter 5 notes packet, section 5.5, operations with complex numbers. Of course, we're going to look at our operations, adding, subtracting, multiplying, and dividing. For addition and subtraction, just combine like terms. Radicals need to be simplified first, remember. So, for example, we have 2 plus 4i plus negative 4 plus 6i. We can just drop the parentheses because there's addition between the two parentheses and combine the like terms. Positive 2 and negative 4 is negative 2. Positive 4i and positive 6i is positive 10i. Next, negative 3 minus 4i subtracts 6 minus 8i. Okay, so we do have to change the subtraction to addition and change the sign of everything that follows. So this would be plus negative 6 plus 8i. And now combine like terms. Negative 3 and negative 6 is negative 9. Negative 4i and positive 8i is positive 4i. 4 plus the square root of negative 9. Subtract the square root of negative 25. Okay, so we need to simplify this first. The square root of negative 9 is I times 3, so that's 3i. So this is going to be 4 plus 3i minus the square root of negative 25 is equivalent to 5i. Combining like terms, 3i subtract 5i is negative 2i. So this would result in 4 minus 2i. Next, 2 minus the square root of negative 8 plus negative 4 plus 2 times the square root of negative 32. Again, simplify these radicals. 2 minus the square root of negative 8. I'm thinking 4 times 2, and the square root of 4 is 2, so this would be 2i square root of 2 plus, I can drop the parentheses once I've simplified the square root, negative 4 plus, we're thinking 16 times 2, and the square root of 16 is 4. 4 times this 2 out in front, 4 times 2 is 8, so this would be 8i square root of 2. The number of steps not shown on paper there. Combining like terms, 2 plus a negative 4 is negative 2, and 2i square root of negative 2i square root of 2 and positive 8i square root of 2 would be positive 6i square root of 2. Okay, so when you're adding and subtracting, again, add and subtract the like terms, simplify the radicals first. Now, for multiplication, we use FOIL when multiplying binomials. Always rewrite any power of I. You will see I squared most frequently. And remember, I squared is equivalent to, I squared is equal to negative 1. Okay, so here we have 2 plus 4i times negative 4 plus 6i. We're foiling. First terms, outer, inside, last. First terms, 2 times negative 4, negative 8. Outside, 2 times 6i, positive 12i. Inside, positive 4i times negative 4, negative 16i. And the last, 4i times 6i, 24i squared. Remember, this I squared is equivalent to negative 1. So this is negative 1 times 24, which would be negative 24. Combining like terms, negative 8i and negative 24, negative 8 and negative 24 is negative 32. Positive 12i and negative 16i is negative 4i. So negative 32 minus 4i. 6 plus 3i times 6 minus 3i. Again, foiling. First term, 6 times 6 is 36. Outside, 6 times negative 3i is negative 18i. Inside, 3i times 6 is 18i. And the last 3i times negative 3i is going to be negative 9i squared. Again, negative 9i squared I squared is equivalent to negative 1. So negative 1 times negative 9 is going to be positive 9. So we have 36 plus 9, which is 45. Negative 18i and positive 18i is 0. So you notice that the product of this binomial ends up being a real number. Okay, why is that? Well, what's true about those two binomials? They're conjugates, right? They're conjugates. Next, we have the product of 2 and then adding the two results. Okay, so let's see. Foiling here, 3 times 1, 3, outside positive 6i, inside negative 1i, and the last negative 2i squared. And that's going to become a positive 2, a plus 2. So let's just combine here. 3 plus 2 is 5. And positive 6i and negative 1i is positive 5i. Now foiling our next set here. 1 times 2 is 2. Outside positive 1i. Inside negative 2i. And the last negative I times positive I is negative I squared. But again, that's equal to negative 1. So negative negative 1 is plus 1. 2 plus 1 is 3. Positive 1i and negative 2i is negative I. And combining 5 plus 3 is 8. 5i and negative 1i is 4i. So 8 plus 4i. Next, we have 3i squared, and then times, we have 5 terms in parentheses. Look inside the parentheses here. Is there anything you can do? Right? We could simplify I to the 4th first. We don't have to, though. We could simply distribute and then simplify later on. So I think I'll just distribute and then simplify later on. Okay, so 3i squared times 3i to the 4th, that would be 9i to the 6th. Remember, I squared times I to the 4th, you're adding the exponents, that'd be I to the 6th. 3i squared times 5i to the 3rd, 15i to the 5th. 3i squared times 2i squared, 6i to the 4th. 3i squared times negative 6i, it'll be negative 18i to the 3rd. And 3i squared times negative 5, negative 15i squared. Now, I to the 6th, that's equivalent to, divide 6 by 4. 4 goes into 6 once with a remainder of 2. That's equivalent to I squared, so which is negative 1 times the 9 is negative 9. I to the 5th, 4 goes into 5 once with a remainder of 1, so that's equivalent to I to the 1st, which is simply I, times 15 is 15I. A big plus. I to the 4th, divide 4 by 4, remainder is 0, and I to the 0 is equivalent to 1. Anything to the 0 power is 1, so 6 times 1 is 6. I to the 3rd is just that, can't be simplified. Or we can replace it with negative I, so let's do that. Doesn't divide by 4, but it's equivalent to negative I. So that would be negative 18 times negative I is positive 18I. And then finally, our I squared we know is equivalent to negative 1. Negative 15 times negative 1 is positive 15. Now combining the like terms, we have I negative 9, a positive 6, and a positive 15 results in positive 12. And 15i and 18i It's 33i. Okay, another foiling here. Let's simplify. Square root of -8. We're thinking 4 times 2, and the square root of 4 is 2. So this would be 2i square root of 2. So 3 plus 2i square root of 2 times 1 square root of -18. We're thinking 9 times 2, and the square root of 9 is 3. 3 times the 2 would be 6. This would be minus 6i square root of 2. Now we FOIL. First term is 3. Outside, -18i square root of 2. Inside, positive 2i square root of 2. And last, 2i square root of 2 times -6i square root of 2 would result in -12i squared. And the square root of 2 times the square root of 2 is the square root of 4, which is equivalent to 2. So we have 3. These combined, these are like terms, minus 16i square root of 2, and I squared is equivalent to -1. So the double negative would be plus 12 times 2 is 24, plus 24. And finally, let's combine. 3 and 24 is 27. So this would be 27 minus 16i square root of 2. Next, 5 minus 3i squared. Well, remember, you don't distribute over a binomial. You don't distribute the exponent over the parentheses. Rather, you treat this as 5 minus 3i times 5 minus 3i, because that's what it is. And now FOIL. First term's 25. Outside, -15i. Inside, -15i. And the last, positive 9i squared. It's equivalent to -1. So this is going to be a -9 overall. 25 minus 9 is 16. And -15i and -15i is -30i. Next page. Some division here. Since I is a radical, if I is in a denominator, it needs to be rationalized. Okay? So we have I here. We have to bring it up to I squared. We multiply by I. And we get 7i minus 2i squared over I squared. This is going to be plus 2. So this is 7i plus 2 over -1. If I divide each by -1, we get -7i minus 2. And it's just customary and standard to write the real number portion first. So I'll change this to -2 minus 7i as our answer. Look at our next one. Again, the I, we cannot keep that. 5 is okay, but I will have to bring up to I squared, so we multiply by I. So we have 4i minus 6i squared over 5i squared. That's -1, so that's going to be plus 6. I'm just going to write that first. So we have 6, positive 6, plus 4i over -5. We'll break that up into the real number part. -6/5 plus -4/5 I. Our real number part and our imaginary part. Next, we have a binomial for a denominator, so we're going to multiply by 1 in the form of the conjugate of the denominator over conjugate of denominator. we do have to FOIL the numerator. It's going to be 2 outside, negative 3i, inside, positive 4i, and last, negative 6i squared. All over, since these are conjugates, the end result is going to be the product of the first terms. 2 times 2 is 4, and the product of the last, negative 3i times positive 3i, would be negative 9i squared. Okay, let's clean this up. That's going to be a plus 6, so positive 6 and 2 would be 8. Negative 3i and positive 4i is plus 1i. That's negative 1 times negative 9 is positive 9, so 4 plus 9 is 13. And again, breaking this apart into the real number portion and the imaginary, that would be 8/13 plus 1/13 I. Maybe try the next one, pause the video, try it on your own, and then start it up again. We have to multiply by the conjugate of 7 plus I, which is 7 minus I. So we're multiplying by 1 in the form of 7 minus I over 7 minus I. Foiling the numerator here, 7 times 7, 49. Outside, negative 7i. Inside, negative 7i. And the last, negative I times negative I is positive I squared. Again, these are conjugates, so the end result would be the product of the first term, 7 times 7 is 49, and the product of the last, positive I times negative I is negative I squared. These I squareds are equivalent to negative 1. So this is going to be 49 plus 1, which is 50. 49 plus 1, nope, that's 41. 9 minus 1, right? Because that originally is a plus. My circle ran over into my addition sign there. So that's 49 minus 1 is 48, minus 14i. Okay, we'll have to split this apart and reduce. Dividing each by 2, we're going to get 24 25ths and minus 7 25ths I. Next, let's rewrite these with the radicals in terms of I. So this would be 2 plus 5i, and our denominator would be 1 minus 4i. So now we need to multiply by the conjugate of the denominator, 1 plus 4i over 1 plus 4i. Okay, more foiling. 2 outside, 8i, inside, 5i, and the last, 20i squared. All over. Since they're conjugates, product of the first, 1, product of the last, negative 16i squared. That I squared is equivalent to negative 1, so we have a minus 20. A negative 20 and a positive 2 is going to be a negative 18. 8i and 5i is 13i. And I squared here is negative 1, so that's plus 16 would be 17. 1 plus 16 is 17. Okay, now split this apart. The real number portion, negative 18/17 plus the imaginary 13/17 I. Now last one of this type, this would be 3 plus 12i over 4 minus I. Okay, so multiplying by 1 in the form of 4 plus I over 4 plus I. A lot of practice foiling here. First term, 3 times 4 is 12. Outside, 3i. Inside, 48i. And the last, 12i squared. Ran out of room here. I'm going to have to go up here. Denominator, 16 minus I squared. Okay, that 12i squared, that's going to become a negative 12, and a positive 12 is going to be 0. 3i and 48i is 51i, and 16 minus a negative 1 is going to be 16 plus 1, which is 17. So we have 51i over 17. So we have just an imaginary part here. A real number part would be 0. All right, trying to finish up here. One thing we have to look at is multiplicative inverse. Multiplicative inverse of an expression is 1 over the expression, which is its reciprocal, right? If we had 2, the multiplicative inverse of 2 is 1 over 2. We want to write and simplify the multiplicative inverse of 2 plus 4i. Or we would first write the multiplicative inverse of 2 plus 4i is 1 over 2 plus 4i. And now we need to simplify it because I, remember, is a radical and it cannot remain in a denominator. So we multiply by 2 minus 4i over 2 minus 4i. Ooh, at least our numerator is easy, 2 minus 4i. Denominator, since they're conjugates, product of the first terms, 4. Lack of motion again, so the lights went out. The product of the last terms, negative 16i squared. And 2 minus 4i over 16i squared. That's going to be negative 1. So plus 16, that'll be 20. So 2 minus 4i all over 20. Now we have to simplify, dividing each by 2. That's 1 minus 2i over 10. And let's split it apart. Real number part, 1 over 10 minus I over 5, or 1/5 I. All right. And we'll do the last one tomorrow together. So this concludes tonight's video.